Ladies and gentlemen, hold on to your seats. We are going full speed into quadratic projections and atmospheric feedbacks. So I hope that's why you're here, right? I wouldn't do that to you. We're trying to make it as straightforward as possible. We want this unified sea level rise projection for South Florida to be as simple to understand so that you really are using it on a daily basis and make it a tool that is useful to many different stakeholders within our community. So again, my name is Dr. Samantha Danchuk, and I work with Broward County. I'm also on the staff steering committee, and I did lead the technical working group under the compact for the projection itself. So hopefully I'll be able to answer any of your questions at the end. So we have been, or not we, my apologies, sea level has been monitored in South Florida since about 1913. So we have a pretty decent historic record to look to as far as the rate of change of sea level over time. And so I had a little animation to kind of draw your eye to the changes that have occurred. And you can see that, you know, it was consistently rising since about 1913. From about 1993 until recently, the rate of rise actually was almost 10 times greater than it was from 1913 to 1992. So there was a real change in acceleration in about that 93 mark. Even more recently, since close to about 2010, hey, I'm not Jennifer. All right, thank you, Nancy. We did color coordinate, but no, I'm not. So since about 2010, it's even doubled since then. But again, I wanted you to look at that animation so that you can see that there are these fluctuations over time, and we expect that to continue, right? Things don't follow a linear track. We are projecting that they follow more of this quadratic path, but really things could happen in steps, right? So acknowledging that change is important, but acknowledging the increase in the acceleration in recent times is also very important. Oh, Nancy. Part of this has to do with our improved understanding of the feedbacks that are occurring. So when you think about greenhouse gases, you know, directly driving a change in temperature, that's more of a direct forcing. But then there's all these other things that occur on top of each other, right? So an example might be that you know, there's a lot of soot and things that are making the ice in the Arctic darker, right? And so that's enhancing the melt rate. As that water, moves into the ocean, it changes the temperature of the ocean, and then so some of those things are causing indirectly the melting to occur faster, and so you kind of got these, these feedback loops that something occurs, then something else occurs, and then the next thing you know, it's either enhancing or reducing the rate of change of sea level. The other thing that's happening is that there's a melting of the frozen ground. So when you think of think of like the tundra and these areas that have had, meters and meters of, frozen ground for thousands and thousands of years, now that it's warm enough, they're starting to melt. And so that gives an opportunity for the microbes to actually be eating some of those, the accessible carbon that's in that soil. And so now those microbes are releasing greenhouse gases, right? Carbon dioxide as they digest and whatnot. So now that's causing more greenhouse gases to occur and increasing the warming. So there's lots and lots of loops like this. And so it's enhancing the rate of change at a rate that we aren't even actually able to completely model yet. And so these are the types of improvements that the technical working group took into consideration when updating the projection because it's really important. To keep science as up to date as possible so that we are reflecting that in our most current design standards. The other thing that's happening that has a real impact locally is that there's a slowing of the Gulf Stream occurring. So by as much as about 15%. And this has to do with the melting that's occurring with the ice sheets. And so what this implies is that, as the currents kind of slow, you're no longer having the flow rapidly go past our coast. And so as it slows, now it almost kind of pushes the water up higher, close to us, right? So before it was keeping the sea level pretty slow as it was moving quickly by. Now that it's kind of slow, it allows this kind of local increase in the sea level that we're monitoring. And so this was something that the technical working group wanted to consider and make sure that we were regionally adjusting the global projections for South Florida. There was an initial projection that was completed in 2011 Since that time, there have been some really important scientific documents as well as national guidance documents that have come out. The one, of course, being the IPCC, so the Intergovernmental Panel on Climate Change, most latest assessment. So the 5th assessment, and that actually projections from there were actually incorporated into the local projection that we developed. The National Climate Assessment, so that also has the curves from NOAA that were incorporated into our projection. And then, of course, the Army Corps of Engineers had released about 3 guidance documents as well for how to plan for sea level rise and updating their projections as well. So we have a few members in the audience today, so I definitely absolutely want to recognize them. But the technical working group was really critical in order for us to develop a regional projection. And so it combined not only the climate scientists that we're so fortunate to have within the region, but as well as engineers and planners and some of the other people that would be using the projection within the community. So if anybody who is in the technical working group, I can see you right in front of me, just kind of raise your hand. So look around the room. I mean, these people deserve a huge round of applause. We spent months and months and months debating and analyzing and replotting and looking at the data together so that we got to a point where we were in general agreement with this projection. So that is a huge amount of work and dedication of their time to this effort, and it really was critical because it has, as Jennifer mentioned, so many implications for the projection that we adopt for the region. So here it is. This is what the projection looks like. You will see it in the guidance document. You will see it on the compact website. And as acknowledged, we've now, many of the municipalities are adopting it, so you'll start to see it in their comprehensive plans. But we tried to make it simple to read, right? There's a series of curves. We have recommendations of how you use those curves. There's a chart at the top that shows you what the actual rate of rise is, correlating to 2030, 2060, and 2100 timeframes. And I'll get into those details, but just so you see, this is basically what the projection is when I'm talking about it. So imagine this was blue for water, but I just wanted to start a little bit with datums because that often comes up and confuses people. And our projection is referenced to the 1992 mean sea level, and it's a measurement in inches. So I just wanted you to understand where that's coming from. Jill, can you stand up for a second? This may or may not work. I come up with these ideas all the time. All right, so Jill and I are not the same height, right? Sure. So I'm going to talk a little bit about elevation. So how tall are you, Jill?
5'5".
Okay, I'm almost 5'11". All right, so if Jill was the datum, I would be 6 inches above Jill as the datum, right? So what if I'm the datum? Okay, so I'm the datum now. Jill would be minus 6 inches below me as the datum. Does that mean she's underwater because she's a negative number? No. Yay. All right. So, perfect. Thank you very much. So here we go. So as I mentioned, the projection is referenced to 1992 mean sea level. I also have included on the left side how that correlates to NAVD 88, which is what designs are based on and what the engineers are using. So that's the North Atlantic vertical datum. And you can see it's a negative number. Does that mean it's necessarily underwater? No. Okay, good. Thank you. Lenny's looking at me like, why are you doing this? Sorry. It comes up a lot. You'd be surprised. So as mentioned, the projection did start in 1992 and was projected forward, and that was a critical decision by the technical working group again to modify it from where it was previously, and this is reference to the midpoint of the tidal epoch. And you can read about those details in the guidance document as well, or we can talk about it later. All right, so you've got mean sea level. And we have a tide, right? So, the tide comes up to mean high water, right? And you can notice that it still only comes up to minus 0.2 NAVD, right? So another negative number, but you're used to that now. All right, the tide goes down. You can see it goes down to mean low water. And all of these elevations can be referenced. It's not how our projection is referenced, but you'll see them in other technical documents. Okay, so now we're moving forward with the projection, right? So we started with 1992. Now the water has rose up to 2015. So you can see that's at about minus 0.5 NAVD. And then if we projected even further and followed that top curve that I'm going to talk about in a second, you can see we've moved up by 2060 to about 1.9 feet NAVD. And so as I mentioned, that followed the NOAA high curve, and that was a projection of 36 inches above the 92 sea level. So hopefully that was as clear as mud, and we will move forward with the projection. But I tried, I'm telling you. From an engineer, it's always difficult, right, to make things simple. Okay, so looking at the projection itself, most of the time, you will be working within the blue shaded zone. So this is, right in the heart of the curve, the projection itself. Projects that have a life expectancy of less than 50 years. So, maybe it's a culvert, maybe it's something, maybe it's, even building that, is only going to be around for less than 50 years. Maybe it's something that you could replace easily. So, you put it there now, but, in 10 years you could, replace it with a newer version, something like that. So something that's easy to adapt or replaceable. Or something that it really doesn't matter if it fails. So maybe it goes underwater and it doesn't have any effect on any other services or, an adjacent structure. Something like that totally falls in line for when you should be using the blue zone. And these are most of your projects. Now people ask, should I be using the top of the blue zone or should I be using the bottom of the blue zone, right? So that's a difficult decision, and that's exactly what you rely on your technical experts to help you work through. And you're going to hear more discussion about that in the panels following. But basically, you just need to decide, right? So if you use the top line, you may have some additional costs, but you're not having to adapt as soon down the road. You have less of a risk of failure. If you use the lower end of the projection, so the bottom of the blue curve, you may have saved some money up front, but maybe you have to adapt sooner than you thought, right? And so you're going to be reinvesting in that infrastructure sooner than you anticipated, right? Sooner than the life expectancy of the structure or the infrastructure, whatever it is. Okay, and so you have to just be prepared for those consequences. And those are the kind of technical decisions that you would rely on your staff to help you work through. So remember, the projection is referenced to 1992 mean sea level, but we are projecting that by 2030, we'll have between 6 and 10 inches of rise from that data. From 2060, we'll have between 14 and 26 inches of rise from that data. If you had used the 2011 projection, Unified Sea Level Rise projection, you'll see that that falls within the projections that we're using there. Remember, about 1 foot by 2030, about 2 feet by 2060, still pretty much falling in line there. One more note. I didn't include it here because I was trying to make this as simple a projection as possible. But the lower curve itself actually comes from the IPCC. So remember I mentioned the Intergovernmental Panel on Climate Change document. So that comes from the projection from the 5th assessment and the emission scenario associated with actually the highest emission scenario. So it is the median of that projection from that curve. The upper line actually is the United States Army Corps of Engineers high projection. And so we combined those two. We projected it from 1992, and we made sure that we were referencing the Key West tide gauge so that it's relevant to South Florida. Okay, you'll also notice in the projection that there is a higher line, right? So you see this orange line at the top of the graph. This is intended to be used for high-risk, critical infrastructure, because the working group, after much discussion, recognized that, as we learn more and more about the feedbacks that I mentioned and the different things that are affecting the acceleration of rise, and we've looked at the record and you saw that there were changes in the acceleration, that there really is a need to recognize that sea level may rise at a rate much quicker than what we are projecting in the blue zone. And if you have something like a nuclear power plant or something that you absolutely cannot let fail, right? Like it's just not imaginable. You need to have something to plan for. And so that's what this orange curve allows for. And this is based on NOAA's high curve. Okay. Also, a lot's going to change between now and 2060, right? So if you are designing a project that either is going to last beyond 2060, or maybe you're in the planning scenario now, maybe it's a type of project where, I won't say that, I take it back. Maybe it's something that, we have many projects that, although they're a great idea today, maybe it takes them 30 years to even get off the ground, and then you've got another couple years before you get to construction, right? Things are not necessarily always quick. If you have something you're trying to plan way off in the distance, you may consider using this curve because it may build in that factor of safety that you need in order to be planning for sea level rise appropriately. Also, if it's a type of infrastructure that can't be adapted, maybe it's absolutely a fixed permanent type of piece of infrastructure within our community, and everything else depends on it. So if it fails, you're causing 1,000 other things to fail. You might want to point to this curve. So by 2060, we're projecting 34 inches of rise according to the NOAA Hive curve, or this critical infrastructure curve. By 2100, it's as much as 81 inches. So that's the kind of the upper limit of what the Unified Sea Level Rise Projection update is sharing. Okay, so back to the projection itself. Now you can see them all put together. So you see our orange high curve running the top. You see the blue shaded zone. That's what you're going to use for most of your projects. And then there's also it's not part of the projection, but just for reference, you'll see a dotted green line. That actually was the lower limit from the 2011 projection, so just in case people were interested. And it assumes that we are going to do everything we've committed to in the way of reducing greenhouse gases, which really isn't a likely scenario. It actually is almost impossible because even if we completely stopped releasing, really reduce greenhouse gas emissions today, it still would take years and years and years before the system was actually slowed down. So it's not actually part of our projection, but just as a reference point. You also see the data of the actual historic record plotted on top of this figure. So you can see from 1992 to about 2015. So you can see that obviously since these projections are based on that data, they're following that trend. And I think that's what I will point out about that. So if you want to use this projection, you pick the year that you're interested in, right? So it's pointing to 2060. Then you look up and you determine where in the blue zone, or if it's a high-risk critical infrastructure, where on the orange line, that you select that value, and that is your rise above 1992 that you need to build into your design standard. Okay. So just to wrap up, I get these questions very often, so I thought I'd start there before we answer any questions from the group. But often if you are an engineer using this for a technical application, you actually need the specific values for, say, year 2031, right? It doesn't help you to just look at 2030 and try and estimate from the curve. Maybe you want the values yourself for other reasons, or you want to use them for modeling. We used, for the Army Corps, so the top of the blue shaded line, we used the Army Corps' Sea Level Rise Calculator, which is available online. And the link is within our guidance document and shows you how to use it, but basically that will give you all the values for the time period that you're interested in. If you need the lower values along the blue shaded zone, we also have those in the guidance document, but basically we will have to give you those values. And the top orange line is also available through the Sea Level Rise Calculator, even though it's a NOAA projection. So that's where to get the data. If you wanted to write a script that projected it yourself, the equations are within the guidance document, so you can do that on your own as well. Okay. So then people say, all right, that's fine. I have an understanding of how sea level will rise, but what's the implication? So you can go to the compact website and find the vulnerability assessments, which actually show the spatial extent of where inundation is expected to occur with 1, 2, and 3 feet of sea level rise. So that's how you can look at that. Also, what does the inundation look like? So there are visualization tools that each of the individual counties have been working on. Some of them are really impressive in the way of kind of 3D renderings of how flooding will occur and what it looks like in specific communities. So all of those tools are linked within the guidance document as well as on the compact website. So often I get the question of, why did you project from Key West? What if I want to project it from Fort Lauderdale, where we are today, right? So we actually, there's a finite number of tide gauges within the South Florida region. There's a tide gauge in Lake Worth Pier in Palm Beach that has a portion of a record. There is a tide gauge, or 2 tide gauges in Miami, and then there's the tide gauge in Key West. Key West has the longest record, and so it's the most appropriate to project from there. But we have provided some references within the guidance document if you wanted to look at an area closer to home. So if you wanted to look at Fort Lauderdale, we'll show you how to do that. Okay, what is projected rise relative to today's sea level? So not everybody remembers what the ocean looked like in 1992. I don't blame you, right? Jason wasn't even here. He was in Chicago. So, he needs to understand, based on what today looks like, what's that rise? And so also in the document, we explained how to do that. But basically, if you were looking, say, 2030, we've got 6 to 10 inches. You subtract from the lower end about 3 inches. You subtract from the higher end about 5 inches. And basically what you're doing is redrawing the projection from the day, today's date in 2016 forward. And that actually adjusts all those quadratic curves and makes a difference. So from today's sea level, we are expecting about 3 to 5 inches by 2030, if that makes sense. Okay, and when will the next update be? So this is really important. Obviously, the first projection was in 2011, so we completed this last year in 2015, so that was only 4 years of time, but there was an incredible amount of science that came to light in that time. We expect the same thing will be happening in the next 4 to 5 years, and so we want to keep current with that, and so you will expect that this projection will be updated within that time frame in the near future. Also, if there's a change in the datum, so we move from NAVD to the next 88 to the next datum, that also would be a reason to update the projection. And so we expect that in the near term, this projection will still always be the right tool to be planning for, but just acknowledge that you will need to check back for regular updates every 5 years or so. Okay, so here's the guidance document that I keep mentioning, and I have a copy of it with me, but basically everything I've been talking about is documented here, and it has been developed by the technical working group in order to be able to kind of make this easy to use. There's even a quick guide in the back, as well as all the detailed science so that you can understand what it's based on, and recommendations for the work group. So I encourage you to look at that, and it's on the compact website under documents. And that's it.